Among the latest breakthroughs is the emergence of a new generation of neural networks known as AI neural networks, or AINN, which promises to redefine the future of artificial intelligence. This paper explores the key features, applications, and implications of AI neural networks, shedding light on the potential they hold for transforming various industries and advancing the field of AI. Introduction. Artificial intelligence has rapidly evolved, and machine learning techniques have played a pivotal role in this transformation. Neural networks, inspired by the human brain, have been at the forefront of AI development. Traditional neural networks have seen significant improvements in the past decade, with deep learning algorithms and convolutional neural networks, CNNs, achieving remarkable feats in image recognition, natural language processing, and other domains. However, a new wave of neural networks, collectively referred to as AI neural networks, or AINN, has emerged to address limitations and usher in the next era of intelligent systems. Key features of AI neural networks. AI neural networks distinguish themselves with several key features. Adaptive learning. AINNs have the remarkable ability to adapt to new tasks and situations. Unlike traditional models that require substantial retraining for different tasks, AINNs can generalize knowledge from one domain to another, making them highly versatile. High-level learning. These networks excel at high-level learning, capable of understanding complex patterns and relationships in data. They demonstrate an exceptional aptitude for real-time problem-solving and continuous learning. Enhanced efficiency. AINNs leverage large data sets and state-of-the-art training techniques, resulting in superior efficiency and accuracy. Their learning algorithms continuously refine and optimize their performance. Applications of AI neural networks. The applications of AI neural networks span across numerous industries. Healthcare. In the field of healthcare, AINNs are poised to revolutionize diagnostics, drug discovery, and patient care. They can analyze medical images, identify diseases, predict patient outcomes, and assist in personalized treatment plans. Autonomous systems. AINNs play a pivotal role in the development of autonomous systems, such as self-driving cars and drones. Their adaptive learning capabilities enable these systems to navigate complex environments, make real-time decisions, and ensure safety. Financial institutions are increasingly utilizing AINNs for risk assessment, fraud detection, algorithmic trading, and customer service. These networks can process vast amounts of financial data with precision and speed. Robotics. AINNs are instrumental in advancing robotics. They enable robots to perceive and interact with the world, learn from human demonstrations, and perform tasks in unstructured environments. Ethical and safety considerations. While AI neural networks offer tremendous promise, their development raises ethical and safety concerns. The high adaptability and learning capabilities of AINNs introduce risks of misuse and the potential for erroneous decisions, especially in critical situations. Ensuring responsible and ethical AI deployment is imperative to mitigate these risks. Conclusion. AI neural networks represent the vanguard of artificial intelligence, poised to transform industries and redefine the future of intelligent systems. Their adaptive learning, high-level understanding, and efficiency open new frontiers for innovation. However, it is essential to approach their development with a strong ethical framework and safety measures to harness their potential while safeguarding against potential pitfalls. As AINNs continue to evolve, they will undoubtedly play a central role in shaping the future of AI and our interconnected world.